6, 7, 8, 9, and I feel like around 7 or 8, the difference the parameter makes can be easily ignored. Next is specular depth. Now, we don't really have a specular material in our scene. I encourage you to try and analyze what you see on the screen. So, we don't have a specular depth parameter. Sorry, we don't have a specular material, meaning the specular depth parameter wouldn't really make any sense at all. So, it doesn't really matter if you leave it as is or set it to 0 or push it all the way up. The parameters simply won't affect render speed. I will leave it as is. Next is path termination power. As we said, this parameter has the potential to speed up render times, but shadows and occluded areas will remain noisier for a longer period. Since this scene has a predominant shadows, it is not a really good idea to try and bump this value, so I will decide to leave it as is. Ray epsilon and filter size rarely need to change. Alpha channel and alpha shadows shouldn't be changed as well. Next, let's take a look at caustic blur. Caustic blur, if you remember, is used to sharpen or blur out caustics, but caustics are generated primarily by specular or diffuse materials. And we already said that we don't have any of these in our scene, which means that the caustic blur parameter, just as specular depth, will have no effect on the render speed, no matter how we adjust it. Next is GI clamp, which, as the name suggests, is used to clamp out global illumination or the secondary indirect light bounces. I'll start with the usual process of bringing it all the way down to 0 and slowly start pushing it up until its effect vanishes. From what I see on the screen for this scene, the value may safely stay to something like 1. The coherent ratio, I can safely put this to the recommended value of 0.4, and once again with the important note that if you're rendering animation, you need to keep an eye on this value because pushing it too high may result in flickering. You may fight this unwanted flickering in some situations by enabling static noise, but this is only a blind guess and it needs to be tested with the current scene. So that is all we had to do for this project. Let's take a look at the picture viewer for a comparison render of before and after. This is the default with a 2048 samples rendered in full HD. The rest of the parameters are left at their defaults. We got render time of 13 minutes and 42 seconds. After the procedures we just made, the render time has dropped down to 7 minutes and 14 seconds, which is a speed gain of 94%. Let's take a look at the same scene but in different lighting scenario. This is with an external HDRI illumination only, without an artificial light source. As you can see, we have 2048 samples once again, and the rest of the parameters are left with the path tracing defaults. Render time is 11 minutes and 16 seconds. After following the already familiar optimization process, the render time has dropped down to 6 minutes and 58 seconds. In other words, a speed gain of 76%. Finally, let's take a look at how to prepare and optimize a scene for animation rendering in the picture viewer. First thing I'll do is click the Edit Render Settings button and select Octane from the renderer drop-down. As we already said, rendering in Octane is a two-part process. Part 1 is scene export, where scene geometry is collected and sent to the render engine. Part 2 is the actual image sampling. This works great when rendering images, but for animation, the part of the process where the scene geometry is collected and sent to the engine may actually slow down the render quite a bit. To solve this, Octane Render for Cinema 4D has come up with a very clever update mechanism called Resend Only Updated Objects. It is used as an alternative to Send All Scene Data, which is a straightforward brute force way which exports the geometry for each frame of the animation. With Resend Only Updated Objects, the geometry is still collected and exported to the render engine, but this happens only on frame 1. From that point on, objects which are moving in the camera view are the only ones being collected and exported. The rest